indexing application to control the sequencing of events within the application. High-speed processing allows efficient data management within the application. This achieves accurate conveyor speed differentials and speed switching points. Its large memory is particularly useful for handling multiple layers of data. These are necessary for capturing the data of each package entering the conveyor. The double precision floating point operation instructions allow higher precision speed setting and switching points to be determined. This also enables more accurate analog control and positioning control to be achieved. Finally, the built-in Ethernet ports of the QCPU can communicate with MuleSoft devices as well as third-party devices. The analog output module allows the CPU to convert digital program values to real analog current or voltage signals to determine the speed of the VFDs. The outputs of the Q68DIN are directly connected to the inputs of the A700 VFDs. Although Q-series I/O modules are designed to offer very fast responses to input signals, some applications need a shorter response than these modules can offer. In this case, the QD60P8G offers isolated input capability, together with averaging, scaling, and sampling functions. The serial communication module provides a way to link the Q-series system to third-party devices. In this application, the serial communication module allows connection to the barcode scanner. The modules can be regarded as communication coprocessors as they support a variety of dedicated communication functions that are accessed via the special CPU instructions. The A700 VFDs feature a number of functions and high reliability that make it an ideal suitor for controlling the conveyor speeds for gapping and indexing applications. The A700 has several modes that can be used to vary the speed of the conveyors. These modes are defined as vector control, VF control, and real sensorless vector control. For this application, real sensorless vector control is recommended as it is specifically designed for applications where high accuracy and response is a necessity. Real sensorless vector control also minimises speed fluctuation as packages with differing weights enter the application. The D700's duty within the application is to drive the paddle diverters. The drive's straightforward wiring, integrated digital dial with LED display, and integrated emergency stop function make the D700 perfect for simple tasks such as the paddle diverter control. The D700's OEC function helps to further optimize current and hence power consumption of the motor. The result is an additional decrease in energy requirements compared to conventional drives. An internal measuring program monitors the aging of the capacitors, and an operating hours counter enables the operator to plan the best time for servicing. Protection overload functions like the phase failure monitoring system for both input and output circuits ensure trouble-free operation. The GT16 provides visual data to the user to monitor and control the gapping and indexing application. This range of HMIs is ideal for standalone or network solutions and feature an assortment of embedded maintenance functions to improve uptime and operations. Terminals range from 15-inch down to 8.4-inch and are available in a wide range of resolutions. Mitsubishi Electric's IQ Work software is a suite of 4 MuleSoft software packages that enable intuitive programming and setup of an IQ platform system, including system network configuration, QNFX series programming, Q-motion controller and servo setup, and GOT1000 HMI screen design. This next generation of software provides a fully customizable, user-friendly environment with the developers in mind. Simulators and additional configuration software have been integrated into the base software, and label programming across the entire system has been implemented. Now users can program their applications using logical names for devices and reference those values from the GOT1000 HMI. Within the CPU, the sequence program holds the algorithm that sits at the centre of controlling the speeds of the conveyors. The algorithm is firstly responsible for calculating the speed differential required between the conveyors. This is done by initially examining the spacing between the boxes and then altering the speed of the conveyors to pull the distances apart between the boxes. The timeliness of when to switch the speeds is also very important. This is carried out using the application's optical sensor to determine where the package is on the conveyor and then to determine when to change the speed of the conveyor. There are also further considerations to consider when gapping on the conveyors. These considerations include the friction between the package and the conveyor, a necessary part when considering the acceleration of the packages, and the temperature of the application. In applications where high accuracy is required, temperature-controlled rooms are used to avoid changes in elasticity of the conveyors. Other points that are considered within the algorithm is the indexing, which is particularly useful when using the pushers, emergency stop and alarms to avoid package mishandling. As an added feature, this solution could include a data logging module to collect lot code and data information. Material handling applications in the postal industry, for example, require a lot of traceability so that packages can be traced if necessary. The Mitsubishi Electric Data Logger module not only tracks this data, but can generate production reports and send out emails whenever an error occurs. Additionally, the Data Logger module is useful for machine maintenance to send notification emails when it is time to replace components within the system. The Data Logger module's report layout can be customized in Excel, up to 64 layouts per report. A CSV or binary file can be created for data and event logging to track products. Part of Mitsubishi Electric's e-factory concept, the MES interface IT, bridges the traditional gap between the factory and office by enabling bidirectional data communication from the production floor to enterprise IT systems, eliminating all middleware and gateway PCs. The MES interface IT control-level direct database access provides users with the leanest solution possible, reducing overhead costs as well as points of failure. Easy and reliable data access across all network control systems creates limitless application possibilities from quality control to logistics management. The application outlined above looks explicitly at gapping control using analog control. Depending on the speed of the application and the CPU choice, network control methods may also be considered, such as SSCnet3 or Ethernet IP. SSCnet3 is Mitsubishi's closed network solution for communicating with servos. However, it also features an option to connect to the A700 drives. SSCnet3 uses an optical network that is not susceptible to background noise that can affect analog control. Ethernet IP is an open network solution that permits usage of third-party controllers to control the application. Sometimes application requirements will request a certain type of controller to be fitted to the application. In these situations, consideration of open network solutions like Ethernet IP may be possible. If A700 accuracy or speed is not high enough for a given throughput, the VFDs can be exchanged for servo products that may provide higher speed and better accuracy. Mitsubishi Electric's range of MRJ3 servos can be controlled through pulse train output or via the SSCnet3 servo network to provide higher levels of throughput for the gapping application. For further information on the Mitsubishi Electric solution for gapping and indexing control, material can be found in 5 separate components: a double-page quick reference guide, a detailed application note, complete programming files, images and movies, and this presentation. All of this material is available on the MEAU website at www.meau.com. Just click on the Industry Solutions link to find your way to the material. And that brings me to the end of this Application Solutions webinar. I would like to thank you for taking the time to listen to this presentation.